Hello everyone, welcome to my chemistry channel BLDASH, short and sweet in chemistry. Now this topic is short revision in electrochemistry. In electrochemistry, so many parts are there. Here one part that is called electrochemical series. What do you mean by electrochemical series? Here, before that we should go to what is standard electrode potential, or you can say standard reduction potential. Both meaning are same. Large number of electrodes can be measured by using standard hydrogen electrode, that is called SHE as the reference electrode. Are you clear? Standard reduction potential, or is called standard electrode potential, can be measured by using SHE, standard hydrogen electrode, as the reference electrode. That means by the help of standard hydrogen electrode we can calculate. The various electrodes can be arranged. So the various electrodes can be arranged in the order of the reduction potential. Suppose so many electrodes you are getting, how can you arrange according to increase of reduction potential? Then here is that means when it is arranged, it is called electrochemical series. Application of electrochemical series. What are the main application? That means relative strength of oxidizing reducing agent. What is the actual strength of the oxidizing and reducing agent? Then here substance which are arranged in the decreasing order of electrode potential, that is decreasing tendency for reduction or power of oxidizing. For reduction or power as oxidizing agent. What is oxidizing agent? Oxidizing agent is one which oxidizes other and itself reduced. So the elements at the top of the table have maximum tendency to get reduced. The upper part, top elements are tendency to get reduced. To get reduced means they themselves reduce. That means it oxidizes other. So they are good oxidizing agent. Are you clear? Top of the table, these are very good oxidizing agent. Then here, if you say the elements at the top, bottom, similarly at the top and the bottom also, you calculate bottom, the lower reduction potential and so least tendency to get reduced. That means they get reduced, it is less, so they may be oxidized. Oxidized means it should reduce other. One which should reduce other, that is called reducing other, reducing agent. So reducing agent is one which reduce other and itself oxidize. Similarly, oxidizing agent means what? Which oxidize other and itself reduce. F2 gas, fluorine gas, there is maximum tendency here. The elements at the top, and now reducing agent what? Oxidizing agent what? Then here you will see fluoride which is F minus. Fluoride ion means F minus, and here fluorine is the strongest oxidizing agent. What do you mean strongest oxidizing agent? It oxidizes other and itself reduced. Similarly, fluoride ion what? Just opposite is the weakest reducing agent. What is reducing agent? Fluoride ion can reduce reducing agent means which reduce other, but it is weak, not so good as reducing agent. Then lithium has the lowest electrode potential. So lowest electrode potential in table has the maximum tendency to get oxidized. So it is a very powerful reducing agent. Lithium ion is the weakest oxidizing agent. When one is powerful oxidizing agent, that means if it is powerful reducing agent, then it is least oxidizing agent. If it is one is powerful oxidizing agent, then it is weakest reducing agent. So what happened here? Conclusion: the substance which have low reduction potential are strong reducing agent, while those having higher reduction potential, that is strongest reducing agent. Calculate the EMF of the cell. How can you calculate the EMF of the cell? EMF of the cell is the difference between the reduction potential of the cathode and the anode. Nowadays, only reduction potential is known, no oxidation potential, only reduction potential. You should calculate, and the reduction potential should be given, then one should calculate. So here, a cathode and anode difference. That means cathode has higher value and anode has less value. So you can calculate it is difference, and it should be a positive one. EMF of the cell is the difference between standard electrode potential of cathode and anode. Both are standard electrode potential. And now you can say E standard electrode potential, and that is equal to E0, that is standard electrode potential of cathode, minus standard electrode potential anode. So here, electrode potential of electrode, that is known as only reduction potential. If the EMF of the cell is positive, when you make a subtraction, E0 cathode minus E0 anode, it should be positive. The reaction is feasible. If it's positive, the reaction is feasible. The reaction is okay. The reaction can proceed. That means reaction is physical in the proper direction. If the EMF of the cell is negative, then reaction is not feasible, and that is in proper direction, and make it feasible, then you should get the positive value of EMF. That means to give positive value of EMF, electrodes are reversed. Which you are taking cathode, now you take as anode. Which is one you take as that is anode, that you should take as cathode. That means cathode reduction potential should be higher than the anode. So you should take as for positive value cathode minus anode. E potential, electrode potential of cathode minus electrode potential of anode. Then electrochemical series help in finding out whether reduction reaction is feasible or not. Just now I told, if its value is positive EMF value, then it is feasible. If it is negative, then it is not feasible. So you should see what is the E0 value of two electrodes. The cathode should be higher than anode. A redox reaction is feasible only if the species has high redox potential is reduced, that is accept the electron. When it is accept the electron, then it is reduced, that means it is feasible. Remember, cathode should be is one having reduction potential higher, and that should be reduced, that is accept electron. Who will accept electron? That means if positive, Cu plus is there, that is your cathode. And here, if or you can say if the value is higher, then it is cathode. Then here, the species which is lower electrode potential is oxidized. That means now here example you can see one is Cu plus 2, other one is Ag. That means Ag. Here what happened? When you see the value E0 electrode potential of standard electrode potential of copper, that is plus 0.34 voltage, silver that is floss 0.80. Now you can observe what is the higher value. That means here electrode potential of Ag is more. That means you can't say that if you see the one reaction, you can say yes, always Cu plus 2 is higher value. No. You should compare the other electrode, what is the potential, what is the standard potential. Now here you can observe Cu plus 2, that is standard electrode potential is 0.34, where copper is where silver is 0.80. That means here you can say is standard electrode potential of silver is higher than copper. That means Ag taken as cathode, and here Cu plus 2, that is E0 Cu value, that is taken as anode. Since electrode potential of Ag is more than copper, then it has tendency to get reduced to compare to copper, because silver is the higher value. So here what happened? It reduced means it should accept electron easily. Then the reaction where Cu plus 2 electron. So here that means when you compare Cu plus 2 and Ag plus 1, Ag plus 1 is act as a cathode, and Cu plus 2 that is act as a anode. Reduction potential copper is less than silver, so Cu will be readily oxidized in comparison to silver. So reaction what happened? Cu loses electron and silver, that is gain electron. Silver, that is occurs readily. Yes, that means copper lose electron easily than silver, because here higher value. So silver will be reduced and copper will be oxidized in the above reaction, which is not feasible. That means if you see silver is reduced, that means, but we know what? Here value is higher. So silver will be reduced and copper will be oxidized. The above reaction is not feasible. Sorry. Now we can observe Cu plus 2 Ag, that is feasible. Then it is feasible, then the reaction where Cu plus 2 gains electron. So reduction potential of copper is less than that of copper than silver, so Cu will be readily oxidized in comparison to silver. So here feasible, are you clear? Feasible means that should be one cathode should be higher value than anode. So other examples, iron will reduce copper plus 2 to copper. Fe, that means reduce. Fe will reduce, mean iron will give electron to Cu plus 2 to change to Cu. Zinc will reduce. With zinc will reduce mean zinc supply electron to Pb plus 2, so that it changes to Zn plus 2 and Pb. So which will reduce mean? That means it will supply electron to others to reduce. So here Zn and Cu plus 2, because Zn losing electron and supply to Cu plus 2 and it is changes to Cu. That means here to predict whether the metal can liberate hydrogen or not, because when with acid, from acid, whether a hydrogen is produced or not. If the metals they should lose electron and 2H plus, then only hydrogen can be obtained. That means if zinc react with hydrochloric acid, then what happens? Zinc easily loses electron and changes to Zn plus 2. And here, what happens? This electron, losing electron that occupied by HCl, react with HCl, combine with HCl, H plus from HCl, it liberates hydrogen. But whereas metals like copper and zinc cannot liberate from acid, that means hydrogen cannot be liberated from acid, which have negative value of reduction potential. Then here negative values of reduction potential. That is why they cannot liberate hydrogen. So hydrogen can get that means as form of H plus and aqueous that from acid can get reduced by accepting electron. Where this electron from where it comes? The metal can lose. The metal can oxidize. Then it lose electron. The electron accepted by the H plus from acid. Then hydrogen gas liberated and called active metals. These metals are active. M, by losing electron, it gives M plus aqua. And H plus, what is having from acid? H plus react with electron, it gives hydrogen atom, and here one hydrogen atom combined with other hydrogen atom, it forms hydrogen gas, or you can say H means half hydrogen molecule. Electrochemical series, which is arranged in according to the oxidation, that means reduction potential, standard reduction potential. Here you can find which is the strongest reducing agent and which one is the weakest oxidizing agent. Similarly, strongest reducing agent and weakest reducing agent. Now, here you can observe when you go up, that is strongest oxidizing agent. When you go down, here you go to down, here you can observe weakest oxidizing agent. Similarly, they also act as when you go up, that is weakest reducing agent, and when you will go down, and here you can observe that is weakest reducing agent, and here it is written oxidizing strongest, but it should be that is a strongest reducing agent. That means electrochemical series totally arranged as that is oxidizing value and reducing value. So only one is there, the reduction potential. And no, there is one oxidation potential. Nowadays only reduction potential. When you will get a reduction potential of any electrode by the help of standard hydrogen electrode as reference, then you can get almost all elements as electrode and value standard electrode potential, that is reduction potential value you can get. And from that electrochemical series is arranged. When you will go up, strongest oxidizing agent. When you will go down, weakest oxidizing agent. Similarly, just oppositely, when you will go up, weakest reducing agent. When you go down, strongest reducing agent. So here we have to we should know that is mean what is electrode potential, what is standard electrode potential, how they will be arranged, and how can you say electrochemical series is very helpful in electrochemistry to calculate EMF, to know the that mean feasibility of the reaction. If not feasible, how to change to feasible. All things can be understood from the electrochemical series. I hope you understood this chapter, that is electrochemical series, and next topic, that is we will proceed to how to calculate electrode potential, EMF of the value, EMF of the cell. So thanks for watching my video.